So let's start today class. Today in the previous class we already started the auto transformer, is not? So in the last class we already explained the definition of auto transformer and their systematic diagram of the auto transformer. So today again we are going to some derivation on the auto transformer, that is nothing but a step down auto transformer. Okay, so just share the screen and then we will continue our discussion. So in the last class we already drive up to the input power and output power relationship. That means V1 I1 equal to V2 I2. Okay. So their systematic diagram you have to just remember. Okay. So their systematic diagram, this one. Okay. So we already explained all these things in the previous class. Now we just write the relation of the transform volt ampere and the conduction volt ampere of the transformer, because some part of the power transferred to the secondary side by the transformer action and some part of the power transferred by the direct conduction method. Okay, so just let us see which component up to the transfer power from the transformer action and the which are the conduction portion. Okay, so as we explained in the two winding transformer also, the mmf of the two winding is equal. That means all the power transfer in two winding transformer by the action of the transformer action, electromagnetic induction effect. Okay, but here all the power, whatever the input power, is not directly transferred through the electromagnetic induction. Some part through the electromagnetic induction and some part is directly conduction, because the winding is some part of the winding is common. Okay. So just in the last class we drive relation up to this part, that means V2 by V1 equal to I1 by I2 and N2 by N1 equal to K. Okay. So mmf of the winding AB is already right here. That means what is the number of turns of the winding AB? From the figure, you observe that that is nothing but N1 minus N2. Is not? The number of turns of the winding AB is your N1 minus N2. And what is the current flowing through this winding AB is I1. So mmf of winding AB equal to nothing but number of turns into current. That means N1 minus N2 into I1. Okay. So next just proceed from this class and then from this point in this point from this class. Okay. So transformer, auto transformer is continue. Continue. Okay. So the mmf of winding AB is nothing but the number of turn product of the number of turns into current flow through the winding AB. So mmf of winding AB equal to number of turns, product of number of turns into current flow through the winding. Okay. So this one is just change here. That means so number of turns of the winding AB is your N1 minus N2 and current flowing is I1. So just write here N1 minus N2 into I1 into I1. Is it? As we know that I1 N1 equal to I2 N2, as we know that I1 N1 equal to I2 N2. So we'll just put here that I1 N1 equal to I2 N2. I1 N1 equal to I2 N2. I2 N2. Okay. So if you multiply this equation I1 N1 minus I2 N I1 N2, is not. So I1 N1 equal to, we can write I2 N2, is not. So just put this relation in this equation. It's MF of winding equal to AB equal to MMF of winding AB equal to how much? N1 I1 minus N2 I2 equal to. So just put here N1 I1 minus N2 I1. So N1 I1 minus N2 I1 minus N2 I1. So from this relation, we can write I1 N1 equal to I2 N2. Is not. So just write here I2 N2. So if we write I2 N2 in place of I1 N1, I1 minus I2 into I2 N1, sorry, N2 into I1. I1. So MMF of winding AB equal to, if we take I1 common from this one is your, what we write here, I2 N2 is not. This one is your, you replace I2 N2. So MMF of winding AB equal to of winding AB equal to take N2 common from this equation, so we can write I2 minus I1 into what? So we written as I2 minus I1 into N2. I2 minus I1 just here. I2 minus I1 into N2. Right here. I2 minus I1 into N2. So you can say that this one is also product of the current flowing in the branch into number of turns. Okay. So N2 number of turns and the I2 minus I1 current flowing through the winding BC. So you may say that this I2 minus I1 is current flowing through winding BC. So IBC of IBC into N2. That means number of turns of the winding BC. Okay. This one is equal to the MMF of the winding BC. This one is your MMF of winding BC. Of winding BC. That means the MMF of winding AB and BC are equal. So transformer action take place between the winding AB and BC. Now transformer action take place between the winding AB and BC. So you simply write here the transformer action take place between the winding AB and winding BC. The transformer action take place between winding AB and BC. AB and BC. So transformed volt ampere is equal to voltage of AB winding and current flowing through the winding AB. So that power takes place from the primary to secondary by the transformer action. Okay. So we can just write here transformed volt ampere is transformed volt ampere amperes is equal to VAB into IAB. Is not VAB into IAB, that is voltage of winding AB and current flowing through the winding AB. So what is the voltage of winding VAB? That means EAB into IAB. So VAB is equal to, if you follow the systematic diagram, that means V1 minus V2 and IAB is your I1. So we can just write here V1 minus V2 V1 minus V2 into I1. I1. And total input power is and total input volt ampere to the transformer is equal to V1 I1 total voltage supply and current flowing through the winding AC. So total input volt ampere to transformer volt ampere to transformer equal to V1 I1 equal to V1 I1. Now, if you want to find the ratio of the volt ampere, transformed volt ampere to the input volt ampere, that means the ratio of V1 minus V2 into I1 divided by V1 I1, is it not? So, ratio of transformed volt ampere to input volt ampere, transformed transformed ratio of transformed volt ampere to total input volt ampere. volt amperes to total input volt ampere input volt amperes is equal to V1 minus V2 into I1 divided by V1 minus V1 minus V1 into I1. So just I1 is cancelled out from numerator and denominator part. So just here calculation of, so that means V1 minus V2 into I1. V1 minus V2 into I1 divided by V1 into I1. Good. So V1 into I1. This I1 from numerator and denominator is cancelled out. So if you divide V1 by V1 1, so V minus V2 divided by V1 is how much? From the previous relation, that is equal to, we can write K. So equal to 1 minus V2 minus V1, V2 minus V1 to V1 equal to 1 minus K. So 1 minus K. That means out of the input volt ampere, that means V1 I1, only VAB IAB is transformed by the transformer action. Is it not? Only VAB IAB is transformed by the transformer action, and rest of the power transformed by the conduction method. So just we write here V1 minus V2 are the transformed to the output by the transformer action. Rest of the, so volt ampere required for the output are conducted directly from the input conducted volt ampere. So conducted, what is the value of conducted volt ampere? That means total input volt ampere minus transform volt ampere. Transform volt ampere we already find out here. Is not? So just subtract this V1 minus V1 into I1 minus VAB into IAB. So if you want to find out the conducted volt ampere, conducted volt ampere is equal to total input volt ampere minus transformed volt ampere. So transformed volt ampere you already find out here. So just put here. So total input volt ampere, total input volt ampere minus transformed volt ampere. This one is your much? Transformed volt ampere. transformed volt ampere, that means VAB IAB, is not volt ampere and is written as conducted volt ampere equal to V1 I1 minus EAB IAB. So that here V1 I1 minus VAB IAB. So minus VAB IAB equal to V1 I1 minus VAB equal to how much? V1 minus V2 and IAB equal to I1. So just put here the value of VAB and IAB. V1 I1 V1 I1 minus V1 minus V2 I1. So V1 minus V2 into I1. I1. So how much we can write here? V1 I1 I1 minus this one is your V1 I1 V1 I1 minus minus plus V2 I1. So plus V2 I1. To I1. So this V1 I1 and this V1 I1 is cancel out. So only V2 I2, V2 I1 is your conducted volt ampere rating. V2 I1 is your conducted volt ampere. So now we just find out the ratio of conducted volt ampere to the total input volt ampere. How much? Ratio of conducted volt ampere, conducted volt ampere to the total volt ampere. Total volt ampere equal to how much? Conducted volt ampere is your V2 I1 and total volt ampere is your V1 I1. So just to divide here. V2 I1 divided by V1 I1. into I1 divided by V1 I1. Given I1. This I1 is cancelled also. V2 by V1 is equal to how much? K. What? That is the ratio of transformed volt ampere to total volt ampere is 1 minus K, and ratio of conducted volt ampere to total volt ampere is equal to K. Is it not? You have to keep this relation in your mind. Now we just what is the advantage of the auto transformer? Okay. So what is the advantage of auto transformer? Okay. Now just we consider one by one what is the advantage of the auto transformer. So one that is over the two winding transformer, that means advantage of the auto transformer over the two winding, the weight of the conductor, that means copper or aluminum for any winding depends upon the cross sectional area and the length of the conductor. Okay, so the weight of conductor is directly proportional to the cross sectional area and the length of the conductor. Okay. Weight of conductor, that means copper or aluminum, whatever you may be used as a conductor of winding. So maybe used copper or aluminum. Okay. For any winding, it depends on the cross-sectional area and length of the conductor. Any winding depends on the cross-sectional area and length of the conductor. Cross-sectional area and length of the conductor. Of the conductor. Conductor area is proportional to the current carried by its, whereas the length of the conductor depends on the number of turns of the winding. Okay. Proportional to the conductor area is proportional to the current carried by its, whereas the length of the conductor in a winding is proportional to the current and number of turns in the winding. Okay. Now, the conductor area is proportional to the area proportional to the current carried by it current carried by it, whereas the length of conductor in a winding is proportional to the current and number of turns in the winding, whereas the length of conductor is proportional to current and number of turns of the winding. Number of number of turns of the winding. Winding. So weight of conductor for winding AB and BC, just find out individual, and summation of these two winding weight is your total conductor of the auto transformer. So just weight of the winding AB written as number of turns into current flowing through the winding. Okay, good. So weight of conductor for winding AB is your weight of conductor of winding AB equal to number of turns into current flowing through that winding. That means AB. Weight of conductor of winding AB equal to number of turns in AB is your N1 minus N2 and current flowing is your I1. So just weight of the conductor is equal to what? N1 minus N2 into I1. N1 minus N2 into I1. N2 into I1. Similarly, the weight of the conductor of winding BC, number of turns is your N1 minus N2 into current flowing is your how much? I1. Sorry. I2 minus I1 So weight of conductor of winding BC equal to I2 minus I1 into is what? I2 minus I1 into I1 into N2. Now, so the total weight of the auto transformer is your summation of these two windings. Okay. So you can find the total weight of the auto transformer and just compare from the two winding transformers. Just we stop here, and in the next class we will start discussing from this point.